As we know that a list is implemented as a circular doubly linked list with a dummy head node in STL. Now let's see how it can implement iterators of a doubly linked list or simply list in STL. So how does an iterator works? So let's say we take an iterator to the first node, right? And this iterator is basically something which contains a pointer to a node, right? So we have this iterator object. Iterator contains a pointer to a node in the list. And how can we use it? So if we want to use an iterator in STL, we have to create an iterator object from the abstract data type that we are using. So for example, if we are using list, we have to use iterator provided by the list class. So we would declare it something like this. So std list, let's say it's an integer list. Within this list, we have iterator, right? And we declare it iterator it. So this is how we declare an iterator. To initialize it with the first value in the list, we say that iterator, let's say this list is L, so we say it is equal to L dot begin, right? So what would this begin function do? It would basically return an iterator to the first node in the list. And we can use this iterator to traverse all the values in the list. So we can say that while it is not equal to L dot end, so while the iterator does not reach the last node, past the last node, we will continue the loop, and within the loop we can just say that cout static it, right, followed by space. So what this dereferencing operator would do, it would basically return the value 1, and to move the point iterator to the next node, we would simply call the increment operator plus plus it. So what plus plus it would do, it would change the pointer to the next node, and then in the next iteration 2 would be displayed, and plus plus would move the iterator to the third node and fourth node, and then when we will call plus plus in the fourth iteration, the iterator would contain the address of the next node, that is dummy head, right? So practically or logically we should not derefer it, right? So and it also reflects that the end function should also return the address of the node which is past the last node, and the last past the last node is basically dummy head in this particular implementation. So the end function should also return the iterator to the dummy head. So that's how we know that we have reached the end of the list. So this is how we use the iterator. So now if we look into the implementation of the iterator, so first thing is that the iterator class is implemented within the list class, and before that list has some functions like begin and end, which basically returns the iterators to the first and past the last node, right? So these begin and end functions, these would be implemented in the list class, and the iterator class would be implemented in the list class as well, but begin and list end functions would be implemented as the functions of the list class, and iterator class would be implemented as a nested class of list class. So we would have something like this. You can also use class instead of type name. I just prefer type name so that students do not get confused with type name and declaration of the class. So we would have a list, right? So within list we would have all its functions, its member variables, and somewhere we would have a nested class iterator. So a class within a class, right? So this is important. And what does the iterator class contain? It basically contains a pointer to a node. So we just take a pointer to the node. That's it, right? So it does not require anything else. And within this iterator, so let's see how many functions we are calling here. So we are calling the not equal to function here, operator not equal to, the dereferencing operator, right? What else? Plus plus operator, and there are a few other functions as well which are called through the iterator object, right? So let's start with any one of it. So let's say we want to implement the dereferencing operator. So what should it return? It should return a value. Now the thing is, if we just want to return the value through this iterator object, returning t is sufficient. But if we want to do something like static it is equal to 5, right? So we want to use this dereferencing operator to change the value. So to use this syntax, it is basically equivalent of iterator dot equivalent of calling iterator dot it dot operator, sorry for the noise, operator static, right? And we set it equal to 5. Now basically this is not a very common syntax of C++, but it is allowed if this function returns a value by reference. So if we return a value by reference in a function, then whatever is written on the right side of the equal to operator is assigned to the value that we want to return. So in operator static, what should be returned? So if it is pointing to this object, we should return this value, right? And how do we get it? We have pointer to this node, and we simply return pointer dot val. So we return ptr dot val. So it should return the value. And now as we are returning by reference, so what would happen? This 5 would bind to this variable val, right? ptr dot val, and it would be stored there. That's it. So that's why we return a value by reference when we are implementing the dereferencing operator. And what other operators we have? We have operator not equal to, equal to. So equal to, not equal to should return a true or false. So, and it should, oh yes. So what happens when we say that iterator is not equal to L dot end? So we have what iterator objects on both sides of the operator, or if we are using equal to operator, we have iterators on both sides of the equal to operator, and on the back end something like it dot operator equal to this function is called, which we are overloading, and the object on the right side of this operator is passed as a parameter, right? So whatever we pass is received here, right? And so this is received, let's say we call this other or right hand side, and this is this is the object for which this function is called. This would be referred through this pointer. So we take this as parameter, this object as parameter, so it should be const, it should not be changed, const, and what it is, it is iterator, and we do not create a copy of it, we just like pass it by reference right hand side. And as we know that if a function is not going to change any member variable, in this case ptr, it should be a const function, right? So we make it read only so that we don't do anything by mistake, any unwanted changes by mistake. Now the object on the left side of the equal to operator is received as this, and on the right side of the operator is received as RHS, right hand side. So we just need to see whether pointers in both these objects are having the same address. So we just return the Boolean expression this dot ptr is equal to right hand side dot ptr, right? So we will just return this boolean expression, and the not equal to operator would also be the same. So I would just copy paste this thing. So in not equal to, so we just change the boolean expression, and we implement the not equal to. So far we have implemented not equal to operator, equal to operator, this operator, and now we need to implement the increment operator. So this is pre-increment operator. We could also have used post-increment operator. So in case of pre-increment operator, so we just overload it as operator plus plus. What should happen? So let's say when the iterator is pointing to this node, the plus plus should make it to point to the next node, right? So what should happen? Pointer should now contain the address of the next node. So if we are at this node, node 2, so how do we get the address of the next node? So address of the next node is in ptr.next. So we simply store ptr.next in ptr. That's it, right? So pre-increment operator is simple. Just say ptr is equal to, we should write this dot ptr is equal to this dot ptr dot next, right? What should it return? So the pre-increment operator basically returns the iterator object, return static this, so the current object itself, and we return it by reference. For the post increment operator, so that if it would also be operator plus plus, but syntactically whatever the data type of the class is, the post increment operator contains int, and it should not return any value, right? So what post increment operator does, so if we have something like this, let's say it is equal to it2 plus plus, right? So value of it2 would be copied to it, and then afterwards it2 would move to the next node, right? So how do we do that? We basically create a copy of the current node. So we say that iterator old is equal to static this. So we create a copy of the current iterator. We move the current iterator to the next node, right? And then we return the copy that we had saved, right? So this is how post increment operator works. So instead of uh, moving it to the next node explicitly, we can also call the pre-increment operator here. So that's it. So we have implemented a few functions for the iterator class. Just to review it, so the iterator class should be a nested class of the abstract data type class, which is list in this case. It contains a pointer which contains the address of a node, and then we implement the functions. And here we close the iterator object. Let's see if we are accessing something from the list. So we are basically not accessing something from the list, so we do not need to make this iterator a friend of list, a friend of iterator class. And let's now implement the begin and end functions. So begin function returns an iterator. Please mind that this iterator, this begin function is part of the list class, not the iterator class, right? So iterator begin, it does not contain any parameter, and it returns an iterator, right? So we need to create an object iterator, IT. We store the address of the node, the first node in this iterator, and return it. So we say that it.ptr should contain the address of the first node, and the address of the first node is in the next part of the dummy head, right? So we say that it.ptr is equal to this dot h dot next, right? So that's it. Now it is, so in this begin function, which is the function of the list, we are creating an object and we are accessing the private member variable of this object. So we are accessing private ptr. It is not possible, so we would get an error. So as we are accessing the some private part of this iterator class, so the iterator class should make list as a friend. Sorry if I have said other way around earlier, but this is the case. So within the iterator class, we should write friend class list, right? So we make this list a friend of iterator, right? So if we make it a friend, then list should be able to access private variables of member variables of the iterator class. If you get some syntax error, just try to write type name before this friend, and if it doesn't work, then try to write template type name u other than the template variable that you have used. Let's say template type name u, and within list try to pass u if it doesn't work. So the begin function, in the begin function we store the address of the first node and we return it, and end function would also be the same. So it would store the address of the node past the last node after the last node. So we know that as after the last node we have the dummy head again. So it would contain iterator it.ptr is equal to this dot h. So it is the node which is next to the last node. Return it. Just as a side remark, so if you initialize an iterator with the end node, like it is equal to end, and then you try to derefer it, cout static it. If you are so I'm particularly talking about the Microsoft implementation. So if you are developing your application in debugging mode, then it should throw an exception, right? But if you have changed the setting to the release mode, then you would not get any error. Rather, you would just see a garbage value or a default value for the data type. Now, a few more things. So as we are implementing the iterator class, there might be a situation in which the list is of some user defined type, like person has um, ID and name. So let's say this is list of persons, and if you want to take an iterator of it, we will take an iterator, and within that iterator, if you want to access the ID of this person or the name of this person through the iterator, we would need to write something like it arrow ID and it arrow name, right? So we also need to implement the arrow function. So as you can see that STL implements iterators as kind of sugar-coated pointers, right? So if we are if the pointer is of a structure, is to a structure, then the elements of the structure are accessed using the arrow operators, right? So we need to implement the arrow operator as well. So in the same way as we have implemented the dereferencing operator. So this arrow operator is basically returning a pointer, right? So the return type would be t static, and then we have operator arrow. What should it return? Address of the value part. So it returns the address of the value part, right? So that's it. So I think this is all the operators that are supported by an iterator. So if I'm missing some function, just let me know in the comments. Maybe I would add it in some next video. And otherwise, if you have any questions, you can ask. To look into the source code of the of the implementation of STL, let's say by Microsoft, just search for GitHub MSVC, and then if you want to look for the source code of list, just search for this thing, and in the top result you should see the source code of the list. I have skipped a lot of details, like as a template parameter I have just used the value type, but in fact the list also contains takes an allocator uh, as a template parameter as well. I have skipped it to get all together, and there are also many other details that I have skipped. I just wanted to keep it to the minimum so you understand the structure of how a list is implemented in STL and how the iterators work. So that's I guess that's it.